Hey everyone, and welcome to this explainer. Today we're completely demystifying how machines actually learn from data. You know, if you've ever watched a sci-fi movie, you've probably walked away thinking computers are these magical beings with minds of their own, secretly plotting in some glowing neon-lit room. Well, we're going to strip away all those Hollywood illusions right now and look at the real logical foundations of machine learning. By the end of this explainer, you'll see exactly what's happening behind the screen. And honestly, I promise you, it is so much cooler and way more logical than any movie magic. So imagine for a second trying to teach a computer to recognize a picture of a cat. Sounds easy, right? But here's the catch. You literally cannot use any mathematical formulas, and you can't give it any rigid instructions. You can't just type out, hey, if it has pointy ears and whiskers, it's a cat. Because, well, a computer doesn't naturally know what pointy or whiskers even mean. It's just a blank slate. How in the world do you teach a completely blank machine without giving it a strict rulebook? That exact puzzle is what led to the entirely new way of computing that we're exploring today. Okay, let's dive into this fundamental difference because it's a real game changer. On one hand, we've got traditional computers. For decades, the absolute only way to get a computer to do anything was to feed it strict step-by-step rules. It was basically like giving someone a baking recipe where they couldn't deviate by a single grain of salt. If a scenario wasn't explicitly in that rulebook, the computer would just crash or totally give up. But machine learning, it completely flips the script. Instead of relying on rules, it relies on examples. Think about how a human toddler learns. You don't hand a 2-year-old a biology textbook to explain what a dog is. You just point to a dog in the park and say, dog. You do it enough times with enough different types of dogs, and the kid's brain just kind of figures out the rest. Machine learning is literally trying to mimic that exact same natural learning process. But wait, if we aren't feeding the computer a list of rules, what exactly are we feeding it? Well, we feed it data. Data is the absolute essential fuel that computers are completely hungry for. Think of it this way. Without data, a machine learning system is like $1 million sports car with zero gas in the tank. I mean, sure, it might look shiny and super impressive sitting there, but it's going absolutely nowhere. To get our machine to learn anything at all, we have to pump it full of a massive, continuous diet of this vital fuel. To be super clear about this, data represents the facts, the numbers, the images, or the texts that we feed into a computer so it can actually learn about our world. For you and me, learning about the world usually means going outside, exploring, trying new things. But for a computer that's stuck inside a metal box, data is its one and only window to the outside. It's the raw material of reality translated into a language the machine can digest. It is essentially the homework a machine desperately needs to study to pass the test. If we want it to learn about the weather, that data is thousands of temperature readings. If we want it to learn how to read, the data is thousands of books. Now here is where humans still have a massive advantage. If you want to teach a toddler what a bicycle is, they might need to see, maybe 3 or 4 bikes in the real world over the course of 5 minutes, and boom, they've got it. Next thing you know, they recognize a tricycle, a mountain bike, even a rough crayon drawing of a bike. A computer? Not quite as fast on the uptake. It might actually need to process over 1 million pictures of bicycles from every conceivable angle in every single lighting condition before it finally gets it. They are incredibly fast at processing the information, for sure, but they need an enormous amount of homework to catch up to human intuition. So once the machine finally has all this data, all these millions of images or numbers, what does it actually do with it? Well, it spots the patterns. Think about how you recognize things in your own everyday life. When you're studying for a math test, you're usually looking for a repeating formula, right? Or when you're playing a video game, you learn the repeating behavior of the boss enemy so you know exactly when to dodge. You're finding the hidden structure in the chaos. And that is exactly what the machine is trying to do with its giant mountain of data. Now, what's really interesting about this process is how this incredibly complex technology breaks down into a remarkably simple 4-step life cycle. This right here is the true heartbeat of machine learning. Step 1, we gather the data. We collect those millions of cat pictures. Step 2, the machine runs its algorithms to find patterns. It starts noticing that in all those pictures, there are certain arrangements of pixels that look like pointy ears. Step 3, it makes guesses. We show it a brand new picture it has literally never seen before, and it guesses, I think this is a cat. And step 4, which is absolutely the most important part, it gets better. If it guesses wrong, it adjusts its internal settings so it won't make that exact same mistake next time. It's just a continuous, never-ending loop of improvement. When the machine is in that phase of finding patterns, it's really just breaking our complex world down into super simple building blocks. It starts by identifying shapes, straight lines, curves, hard edges. Then it recognizes colors and how they contrast with one another. If it's looking at text or numbers, it's finding sequences, like which word usually follows another word. By finding these simple, fundamental elements hidden inside that massive pile of data, the machine slowly begins to make sense of the world. It pieces together those shapes and colors until it finally realizes, oh, I'm looking at an apple or a car or a dog. I want to take a quick second here to reassure you about something. Just like us, the machine rarely gets it right on the very first try. Think back to when you first learned to ride a bike. You probably wobbled, maybe you even fell over a few times. You made mistakes. But that wasn't a failure, right? That was literally just you learning. It is the exact same thing for a computer. Making mistakes is a crucial, entirely unavoidable part of the machine learning process. Every single time it guesses wrong, it essentially says to itself, okay, well, that didn't work. Let me tweak my approach. Practice really does make perfect, even for a supercomputer. And this brilliantly illustrates how that practice plays out over time. Look at try 1. The machine's accuracy is incredibly low. It's practically just flipping a coin. But jump over to try 50, and it's already learned from its past mistakes. Its accuracy reaches a medium level. It's getting the hang of it. By try 1000, after consuming way more data and adjusting its internal patterns hundreds of times, the accuracy goes through the roof. The machine becomes an expert, not because someone programmed it to be perfect right out of the box, but because it was allowed to practice, fail, and try again 1,000 times over. So, the absolutely crucial point I want you to take away from this is machine learning is really just practice and pattern recognition. I want you to remember this quote whenever you hear someone on the news or the internet hyping up artificial intelligence as if it's some incomprehensible alien wizardry. There's absolutely no magic inside the computer. There's no tiny secret brain in there thinking human thoughts. It is simply a highly efficient cycle of data-driven practice. It looks at the data, it finds the pattern, it makes a guess, and it practices until it gets it right. That's the whole secret recipe. Now, you might be sitting there wondering, okay, that's a neat trick, but why does this actually matter for my future? Well, it matters because this deceptively simple process of data, patterns, and practice is fundamentally changing our world. By stepping away from those rigid, old-school rules we talked about at the very beginning, we have completely unlocked the ability for computers to tackle messy, complicated, real-world problems. Stuff that a human programmer could literally never write enough rules to solve. This incredible pattern recognition is being applied all around us right this second. 30% of these applications are things you use every day, like recommending videos, finding the pattern in what you enjoy watching so it can show you more of it. Another 30% goes toward translating languages, finding the complex patterns between English and Spanish text to break down global communication barriers. 20% represents incredible medical help, where machines look for tiny patterns in X-rays to spot diseases much earlier than a human eye ever could. And another 20%? That's self-driving cars, where the machine learns the pattern of a stop sign versus a crossing pedestrian to navigate our streets safely. These are massive global problems being solved, simply because we figured out how to teach computers to learn from examples. Which brings us to our final and honestly most exciting question. Now that you know the big secret, that machine learning is just feeding data to a computer so it can find patterns, how might you use it? Because listen, machine learning is not just for huge tech companies or scientists wearing lab coats. It is a tool. It's a tool just like a paintbrush or a calculator. So look around your life, your school, your community. What messy problems or hiding patterns that a machine could help you solve? The future of this technology isn't just about what machines can learn. It's entirely about what you are going to teach them next. Thanks so much for watching this explainer.